welcome back. In this video, we're going to look at how to talk about direction, form, and strength when we're describing the association between two variables. You can pause the video and read the example and then unpause when you're ready. If you travel overseas, you know that what's really important is not the amount in your wallet, but the amount it can buy. UBS, which is one of the largest banks in the world, prepared a report comparing prices, wages, and other economic conditions in cities around the world for its international clients. Some of the variables it measured in 73 cities are cost of living, food costs, average hourly wage, average number of working hours per year, average number of vacation days, hours of work needed to buy an iPhone, minutes of work needed to buy a Big Mac, and women's clothing costs. For your burger fix, you might want to live in Tokyo, where it takes only about 9 minutes of work to afford a Big Mac. In Nairobi, on the other hand, you'd have to work almost an hour and a half. Of course, these variables are associated, but do they consistently reflect costs of living? Describe the associations shown in each of these scatter plots. So anytime we're asked to describe an association, we want to mention three things, but also add a fourth one in. We want to talk about direction, form, strength, and then also I'm going to throw in there any potential outliers or clusters of data that are away from the rest of the data. So in our first scatter plot A, how would you describe the direction, form, and strength? And are there any outliers? So when we say direction, we're talking about, is it positive or negative? When we say form, we're talking about, is it linear or is it nonlinear? And when we're talking about strength right now, we're going to be discussing a term called correlation, which measures the strength of an association between two quantitative variables. And the association needs to be a linear association, okay, to make it important. But for right now, for strength, we're going to look at, does it have, a weak association? Is it moderate? Or is it strong? Okay, and all of that relates back to correlation. So in letter A, I would say that this is a positive association. So we always want to mention in context, we would say the association between, what two things am I comparing here? Food costs and cost of women's clothes. Appears to be positive because it's going up from left to right. It typically, as the cost of women's clothes increases, the food cost increases. And it looks pretty straight to me. Okay, there's a couple stragglers with a few high outliers, and those would be like these points here, maybe these ones here. And I would say it's moderately strong. So how do I know that? Well, it's going to be easier when we talk about correlation and discuss when we have a number to actually quantify to determine whether it's strong, medium, or weak. But right now, the points are pretty close together and they're pretty much making a line. Like I can determine that a line can go through some of those points. So I would say it's moderately strong. How would I know if it's strong? Well, if it's making like more of what appears to be a line. And how do I know if it's weak? If it just looks like there's random points that are scattered where there is no, form there. So for right now, we'll just say moderately strong. In letter B, we're looking at average hourly wage and hours to earn an iPhone. So we would say something like the association between average hourly wage and number of hours to afford an iPhone appears to be negative because it's sloping down to the right. In other words, as the average hourly wage increases, the number of hours to earn an iPhone would decrease, which, I guess in that country makes sense. I would say this is non-linear. Okay, it's definitely there's a curve or a bend there, and it's very strong. However, this very strong may not be very relevant because we don't have a linear association. Okay, but we're going to talk about that. Okay, but there definitely is a very strong relationship between average hourly wage and hours to earn an iPhone 4S. Now you can try to on your own and then unpause it when you've answered both C and D. So take a look, what's the direction, form, strength, and discuss any outliers. And remember to write up your answer in context. So in letter C, I would say that the direction here would be negative, because it looks like generally the cluster of points is sloping down to the right. Okay, I wouldn't draw a line going this way. It looks like more of them are decreasing. The form looks like it is straight. Okay, so it's more scattered, but they fairly are clustered in the same area, sloping downwards. I wouldn't say it's nonlinear. There's really no bend there. And the strength, I would say, is pretty weak. And the way I know that is it's not really forming a line, right, or forming any kind of shape. It's more scattered than anything. And it appears that there's maybe like 2 possible outliers. In letter D, I would say the direction, there really is none, right? So there really is no association between vacation days and food costs. And that means I don't need to talk about the form. The strength I still could discuss, it would be weak. And it looks like maybe there's an outlier there. Okay, so the form, it's not really linear. It's kind of scattered all over the place. And like I said, strength is weak. Variables can play different roles. The variable of interest, it's also known as the response variable or the y variable, is plotted on the vertical axis, right? So vertical is up and down. So if we go back to letter C, clothes index would be my response. And then the explanatory or predictor variable, okay, we're using x to predict what y is the x variable, and it's plotted on the horizontal axis. So working hours would be the explanatory or predictor variable. And it's very important which variable we decide to go on which axis, right? So our response variable is our dependent variable, right? And our x variable, our predictor explanatory, is our x variable, and that's our independent variable. So we're using the explanatory variable to predict the response variable, okay? So in other words, can we get working hours to predict clothes index? Can we get vacation days per year to predict food costs? Sometimes it doesn't make sense to switch the x and the y because that association would be meaningless. We want to use our TI-84 plus calculators to create scatter plots. Okay, so I'm going to create one on my TI-84. And the data here represents the average annual levels of carbon dioxide in the Earth's atmosphere for selected years. And then it's measured in parts per million. Okay, so I'm going to create one, and you should follow along too on your TI-84 plus. And then you can just copy that graph into your notes. So what I need to do is go into stat, because I'm entering in numbers. This time I'm entering two sets of numbers. So as you can see here, I have data in L1. And remember, if I want to clear that, I just want to highlight L1. So you'll hit the up arrow until your cursor's on L1 and then hit clear. And then you'll just hit the down arrow. And we're going to put the explanatory variable in L1 and the response variable in L2. So my explanatory variable is going to be year here. That's going to be my predictor for carbon dioxide levels, right? So year is going to be L1. So we're just going to enter those in as we see them. So 1981, 1986, 1991, 1996, 2001, 2006, 2011, 2016. And then hit the right arrow to go to L2, and L2 is going to be my carbon dioxide levels, so that in parts per million, so that would be 340, 347, 355, 362, 370, 381, 390, and 403. And now to create my scatter plot, I want to turn my plots on. So I want to go to second y equals. And this time you're going to make sure your plot's turned on. And for the type, you're going to scroll all the way to the end. Or actually, it's the beginning. It's the first one right there. Okay, that's my scatter plot. And then you're going to click enter. And just make sure your X list is in L1, my Y list is in L2. And now I want to graph. So to graph it, you're going to go to zoom 9. Okay, and then there's your graph. So you can see that the predictor variable, your explanatory, is the x-axis, it's the years. And we're using that to predict the carbon dioxide levels, which is the vertical axis, or your response variable. So you can take this picture and then, you can sketch it onto the graph, the grid that's given. Okay, so again, we had year is our explanatory. Okay, easy to remember. Explanatory has like the prefix X in it. So remember that's your X. It's also known as the predictor variable. And then the response variable is your Y.